Saul Diez-Guerra. I'm a Spaniard in New York. My background is in electronics and computer science. I'm the CTO of a company called Thinkful, where we're trying to prepare people for a better tomorrow. I partly do this because I used to work in ad tech, where I used Python to get you guys to click on ads for a better tomorrow. So I might have targeted you in the past. As payback, you can target and track me on that email, that handle in GitHub and everywhere, except for Twitter, where I am definitely, because I can't really let go of that handle. So what's this Thinkful thing? And I'm going to take some error in because the description's a bit too much. Thinkful is a mentor-led, project-driven, self-paced online tech school that gets software professionals job ready. Now that's, a lot of hyphens. It's really, really dense. So what we're going to do is we're going to stop there and go a little bit about what those things mean. What I mean when I say mentor-led is this strong belief that we have that the human component in education is paramount to like get people to understand things. Or going back to denser words, to achieve full understanding of a body of knowledge, we believe that it's much more efficient to get a trusted peer to deliver that knowledge. There's an article by Atul Gawande in the New Yorker a couple of years ago called "Slow Ideas." They wanted Indian maternity wards to follow some basic guidelines to have kids not die during birth. So they gave them a checklist, which is what Atul Gawande is famous for, the checklist manifesto. What was funny was 2 years after they got the checklist and after they had the checklist and, hanging on the wall and everything, they weren't following the checklist. Kids, newlyborns were still dying. So what they did was they got an army of volunteers to go to the hospitals and do nothing but talk to people, remind them that the checklist was there, and ask them, hey, have you been doing this recently? What really struck me as interesting was that a person that wasn't following that checklist before started doing it, and when asked, hey, why did you start doing this? The answer was, well, I did this because this person was nice to me. So that trusted peer tends to have a lot of impact on the educational outcome, and it might be a mistake to try to remove the human element from education. Project-driven is a much easier one. Most of the time, especially in technology, you learn by doing. And while doing, the story of what you're doing, the context, also helps you achieve that, the wanted understanding of the subject. Self-paced is basically because, especially nowadays, and especially when you target adults, people have different personal situations, people have jobs, people have families to tend to, and you want the education to be flexible so that they can start and stop when they're able to actually attend to the curriculum. And finally, job ready, and I'm gonna even rant more on this one because I strongly believe this is a problem for all of us in here. And if there's a takeaway from this talk, I hope one of them is this. This is an assumption that Thinkful is partly based on, but I also personally think it's really true. which is the tech industry is immersed in this macroeconomic trend for which we have to be really cognizant. What that means is, we need to pay attention, we need to pay close attention to this. That trend is the fact that there's not enough people for the jobs we have. And, that's not because there's not enough people on this planet, but rather because we can't teach people fast enough. I'm going to opportunistically use the help of Mary Meeker's Internet Trends report from last week to drive this point. There's a slide that plots population growth and jobs growth. Obviously, that's actually people working, not demand for jobs. Now, the trick here is, sure, it's really frightening that the population is growing faster, much faster than the jobs, but also, especially for our industry, we got to realize that the demand's there. We just simply can't catch up with it. There's demand for skilled professionals, and the education system is failing to supply enough skilled professionals. Also, there's another problem at play here, which is the growth of cognitive intensive jobs is outpacing all other jobs. And what that means is that more and more people will be working that A, will need more education to get to that first job, and B, will need more maintenance work on their education. You can't just learn COBOL and have an entire career on that. Same thing, you can't learn Hadoop today and retire doing Hadoop, or probably you shouldn't try, I guess. You will actually need to recycle yourself and learn things along the way. And learning is somewhat difficult when you have kids and a life, basically. And then there's the millennials with their emojis and emoticons. They just took over the boomers, and they are the largest generation in the workforce, and that has some impact. The millennials not only will bring emojis to your email client, they will also bring different expectations. The millennials expect training, and the millennials expect flexibility. The more millennials we have in the workforce, the more training we're going to have to provide for them, and the more flexibility we'll have to provide overall. Or, we can try to subvert them, but that's probably not going to work. The younger generation always wins. With that, I hope this is not sounding like I'm preaching to you, that I'm not pitching you my business, because that's not my intention. We're a funded company, we're doing well. The point of this is a problem. I think we all should be aware of it, and we should all try to, within reason, help with it. Resources of many kinds, like ebooks in GitHub, conferences like this one will spawn and will probably help the situation. And of course, the edtech industry is booming, and Thinkful or other companies might, come to a breakthrough. And, so far, other than fancy beards and really bad PowerPoint, we've also taught 4,000 students, of which around 20% have taken either our Python course or Introduction to Data Science in Python course. And I'm going to go over what we learned while doing this. Now, our original approach to building the data science curriculum was to build this minimum viable course in the best lean startup spirit, which would give you the very basics. It would give you, the things to help you get by, recipes and formulas with not that much understanding. Turns out, surprise, surprise, that isn't really helpful, because there's a baseline that's missing and that we also needed to provide. You can't just you don't necessarily need to be proving theorems to be a junior data scientist anywhere, but you have to have a solid understanding of how things work if you want long-lasting skills that are not just, I did a tutorial once. Because of that, we've gone from recipes and formulas to presenting use cases for each tool so that you can actually grok the utility of the tool, and so that eventually when you bump into some problem, you're actually able to pattern match and use that tool efficiently. One of the biggest problems with data science in particular is that it's a really broad topic. People coming in, people wanting to learn data science are not just software, computer scientists or statisticians, but there's also biologists, there's also sociologists, and a whole different range of people that want to do this. And with that, you really don't know what to teach them. Different people will have different abilities that they need to brush up on. And it's really difficult to actually build a data science course that's effective for many people. Josh Wills, during his keynote, presented his tweet, which is not just funny but also really true. And the reality is that a data scientist is half an engineer, half a statistician, and some other things too. And what we found was that the problems people face are either technical or math related, basically. The technical problems tend to be, well, they don't know how to code at all. They don't know programming, or they might be doing, they might be writing operating systems at Microsoft. Or, the middle ground, which is some guy that comes in and tells you, oh, I know how to code because I did C in college 20 years ago. And you have to prepare for all those levels to be successful. Then, in our case, not everyone necessarily was familiar with Python. And some people have really weird backgrounds. Maybe they're, Java programmers, or maybe they know Visual Basic script. They even might be as troubled as being JavaScript programmers, God forbid. But in general, you have to. We've had cases where we've had to turn people away into our Python course because they couldn't take data science if they didn't have a basis. And then, depending on programming proficiency, some people are not able to wrangle with libraries to do what their library should be doing, but the library is not doing because the documentation is wrong or who knows what. And all those things are small frustrations that we have to fight against so that people actually continue to learn and eventually succeed at learning data science. One particular case of technical problem we found is setup. Getting yourself, getting NumPy, SciPy, getting all that stuff up. It's work. We swear by and are really grateful for Anaconda. With that said, every now and then, there's some problem with someone that, Matplotlib is not doing what it's supposed to be doing. That moment, when they are starting out, that moment is critical. If someone starts feeling frustration when they're even installing the package, you can lose them right away. And we have to fight that during the course. On the math side of things, if someone doesn't have enough math background, there's no use in explaining what a convolution is because they will take forever to learn what it is. And if they do, they might not like it as much. And then statistics, unless people have a good background in statistics, statistics tends to be a topic where most people have trouble. And if you don't agree with me, I suggest you bring the Monty Hall problem in your next Thanksgiving dinner. I'm sure it will be a blast. So that's the biggest problem, and now we're going to talk about the power of the mentor, the power of the teachers that we that we get help from to actually get people to succeed. We have a wide network of mentors that are all across the globe helping our students. And the work that these people do is key to the entire educational experience. We're definitely all about that mentor-led experience. We swear by it, we wouldn't have it any other way. A mentor, as they onboard a student, they're able to really, really quickly, and regardless of whatever the student's self-assessment was, which is usually delusional, or sometimes at least, a mentor can actually tell where this person is. A mentor can steer them into the right part of the curriculum. Oh, Python, then skip this and go all the way here. Or, hey, I feel like you don't know enough Git, so you're going to do this Git tutorial we have here because you really need to do this. They also can recommend supplemental reading or work whenever they feel like someone's, for some reason, not up to date with, I don't know, how HTTP works, for example. Also, given that the data science industry is itself, if not new, at least renovated, people come in with preconceived ideas about their ability to make progress, their career prospects, and so on. So the mentor setting expectations for them, the mentor saying, hey, listen, I know you want to become a data scientist in 3 months, but it's probably going to take you 9 months. Here's the pathway so that 9 months from now you can actually do this. Getting people on the right track and managing that, it's key to someone staying with it and finishing, or just bailing and saying, this was too difficult, I don't want to do this. People have a lot of, especially people that never have worked in tech, will have lots of questions about the industry, about what it means to be senior or junior, or what the data scientist role really is at the workplace, and so on. And of course, people want to know how much they should be making once they're out, and all that. We don't necessarily stress. We're not there to sell them the dream of becoming a data scientist. We're not selling them the unlimited growth and unlimited job opportunities and whatnot. We try to damper that a little bit. There's what's really important is that people actually learn. Also, there's the promise of placement is somewhat of an issue in the industry right now. You will get boot camps that are like, yeah, we'll place you. You'll get a job and it will be more than 6 figures for sure, and so on. We're not doing that, and I think it's a better idea to focus on what people learn and go from there. And the last thing the mentors do is steward the community. We do have, given that we're online and it's a global class, we do have a Slack community online. It's amazing what mentors can do and what students can do with each other. The amount of learning that happens in there is great, with very few nudges from the right people to get people talking in the right direction. And with that said, we're going to talk a little bit about the curriculum and how we built it and what we learned. We started out contracting the experts. If you want to teach data science, you'll go to the guy that wrote the biggest library, and you will tell him, hey, help us write this. We didn't do it for data science per se. We did it for other tech courses. And the case for experts is so that they're experts in what they're doing, but they're not experts in teaching. They're not experts on writing. And you will end up editing for clarity, and you will end up editing for pedagogy, and it's just really hard to make that work. Building quality content is absurdly expensive. The cost is brutal, both in terms of resources and in terms of time. And we found some solutions. The first solution is, let people that are good at building content build that content. So we've turned it into licensing best-of-breed content instead of building it ourselves. and supplementing that with mentors, as opposed to having this blind fixation on getting the best educational outcome. That fixation will eventually cloak diminishing returns, and you will end up bleeding through the nose building quality content. So definitely listening from the best of breed has been a really good call as of late. Lack of prior exposure to programming for the data science curriculum was a big problem. We found that we couldn't really address that in the course itself, but rather what we needed was a mentor that was understanding and supportive, a mentor that told you, hey, you're not there yet, you should take this other Python course or this other even front-end kind of course to like start learning what an if-else is, and then work from there. Again, the main goal there is to reduce the frustration people feel. Otherwise, they'll give up. And yeah, the dropout by overwhelm, frustration is the biggest killer in our educational funnel, if you will. Git education has also been a really great bang for our buck. Even people that tell you, yeah, I know Git, I have a GitHub, really benefit from taking a Git primer that's maybe a week or so of work. And then, of course, the lean feedback machine, getting fast feedback on our curriculum, getting any kind of error that we have in the curriculum, getting there fast improves the curriculum much faster than trying to aim high and do it right the first time, which is fairly obvious. That brings us back to the MacReady and the plane that needed to be rebuilt in months instead of hours of Josh Wells' keynote. With that, I'm going to drive attention to two methodologies that we've been using and that have been really successful. The first is pretesting. Quick raise of hands. Who knows what pretesting is? Not bad. For the rest of the people, I'm going to stop for 10 seconds and let you try to come up with an educated guess of what pretesting is. And then I'm going to ask some of those who didn't raise their hands. All right, I'm not going to ask anyone, but what you just saw is basically what pretesting is, which is posing the question before even giving you the answer. It feels kind of nuts, but it actually improves the long-term success of the education process. Kids that will flunk an exam that they obviously weren't prepared for will eventually do much better in their final exam. So we're applying that to our curricula, rather. There's a link there that I'll tweet later, and I guess we'll upload the slides. There's a link there to a good article about that. And the second one is the whole project-based education, which is not just something we say, but something we do. We tend to present a tool or whatever software thing we're trying to teach people, then we present a problem, and then we get out of the way and have them try to, connect the dots. We let them fly the plane. The goal for this is not to become a problem set where you just go through emotions of, oh yeah, this is this, so I'll do this, this, and this, but rather to challenge people into figuring out which tool is the best tool for the job. In that, we've found that, as I was saying earlier, the story and the context matters a lot. So instead of using, say, the Irish flower dataset, which is an industry standard, basically, we use city-back data. We have people, we're not going to have time, I guess, to go over it, but we have people actually pull the New York City city-back API in real time, and they analyze it, which is really cool, as opposed to having them do feature analysis to like a stale set. The same way, if you're doing image processing, Lena here is, again, another industry standard, but Taylor Swift might do just as well, and it's more fun, right? So we do that. I don't think we have time to go into detail about the projects, but basically, we actually have people wait for an hour and gather data, intake data, real-time data from Citybike. And then the Pirate Bartender project is a really simple introductory Python project that's really fun. A couple links here to capstone projects that graduates have done. You can get the slides later. Really, really fun to see what people are capable of after 2, 3, 4 months of part-time education. They will be creating IPython notebooks. They will be doing plotting, model fitting. It's amazing. And with that, and to finalize this, I'm going to go over where we want to go next in regards to the curriculum. We've identified some things that are basically lacking, not in methodology, but just in the real sense. One is model fitting, the whole process of trying to fit a model, trying to make sure it's the right one, and so on. I guess when we wrote the curriculum at first, we underestimated how long it takes for people to actually interiorize that process. Then database is something that we have some of that, but not too much, and people love it. It's not just that people love it, but it's actually kind of the end game sometimes. It's just presenting your results, which brings me to the third point, which is communication. The course doesn't do a good job at telling people how to behave professionally, how to present their results. You can fit your models like no other person, but if you fail to communicate that to your boss or to laymen everywhere in the company, you'll fail as a professional, so we have to get better at that. And other than that, in terms of methodology, we want to increase that mentor-led, that human component of the whole educational experience, which is, again, we believe, and we have proof to believe, that's one of the key factors of success. As any other startup, we started out with a niche product, which was just, you have a mentor session once a week, and it's going to take you around 3 months and so on. But people ask for different things because, again, people want flexibility. And we found that, the more time you spend with your mentor, the better you're off. So we're starting to offer that, and we're starting to prove that that's a good move. We're also experimenting with the office hours concept, which is obviously a really old concept, but we're obviously doing it online and in our own way. It's really early to tell whether that will turn into, say, a book club-like experience or mentors doing lectures, but it's definitely interesting. And at the end of the day, what we really want to do is reduce what I call, tongue-in-cheek, the median time to mentorship, which is basically the time that it passes since from the moment you get stuck and you start feeling that frustration and you start feeling bad about yourself because you're too stupid to get this, till you actually get unblocked and that problem's solved. Minimizing that, it seems, given our type of education, as the biggest thing we can do. Other than that, as our students graduate, as we're taking more experienced students, as we're taking more people that have been around for a while, we need to start thinking what people want to do next. After an introductory data science course, what's next? Next time around, you won't need as much hand-holding, you won't need as much encouragement, you won't need as, you're doing well, you're not intimidated anymore by code or by problems or, SciPy is not doing what it was supposed to. But people still want to be part of that community. People still want to hear from a mentor that in reality is, a data scientist at blah or an engineer at blah. They still want to be part of that, and they will still benefit from that. So access to that kind of mentorship and access to more discrete topics seems like it's one of the next steps. Somebody was asking me yesterday if we had a course on time series. We don't, and I told him that at this moment we probably couldn't provide that, but it's an interesting idea down the line. So to recap, please keep in mind the whole macroeconomic job trend. I know it sounds kind of abstract and whatever, but I think it's important. We will only fix that, and everyone in the industry and in the society as a whole will be better off if we improve education to catch up with that demand for skilled workers. And that goes through making education flexible and accessible in many ways. Data science is too broad. It sounds like it's not going to change anytime soon, but the human component helps a lot. Mentors help a lot. And again, as specialization is more demanded, we will try to specialize while conserving the original precepts of flexibility and that human component, which is what really has done it. And I think that's it. Thank you.